we talked a minute ago about what it means for the probe card companies, the load board companies, people who make consumables.
Mm-hmm.
Talk a little about, remembering he's not going to capture that, talk a little bit about what you think it means for them and what it means for Freescale from their perspective.
I think the challenge is twofold. One is, how do we take what we do today at the test level, and how do we ensure that it's standardized, so we only build one probe or one test card, for example, for a range of products, so we have a standard that we build from. The second is, how do we take a lot of that test activity and bring it back to probe? So it may be that the probe card vendors have to become more sophisticated. We may be asking them to do more things back at the probe stage, more of the physical stimulus that we talked about, and somehow driving more data and more data capture at the probe stage as opposed to final test. So it may well be that it becomes a much more sophisticated part of the process, actually.
It gives me great opportunity for a next sort of level of question, and that is, today there's a probe card, a tester, a handler. Is there value for Freescale in that being more integrated from the supplier perspective, because data is so important now?
The challenge is going to be, can we integrate at the appropriate cost? So today, while you have the various vendors and you tie everything together, if you have someone who is bringing you an integrated system where there's a minimal input, a board, for example, yeah, of course, that's a much more attractive option, but it has to be a cost-effective option. For today, if you could put together a system for $1 million to do everything for you, and you can buy one off the shelf, but it's integrated, but it's $2 million or $3 million, then it's not going to work for you. So it has to be ease of use and ability to use and cost of use. So those things together, I think, will drive the application, will drive the adoption, depending on what you have available.
Great. So Freescale is fabless, fab-light, and data is everywhere. Your proprietary data is everywhere. Who owns the security of that data, and how do you ensure that?
That's a really great question. Who owns the data is going to be divided at certain levels as you go through the system, obviously, and depends on the layering of the software. But from an expectation, certainly our customers are expecting a high degree of software and data security in the product that we sell them. So the capability, there's a firmness, if you like, or firmware that says you're protected inside our devices. You can't break through our algorithms. You can't break into our device. But then when it's in the system, then is there a different way to go and access at a board level, and then once it's in the final application level? I think there's going to be degrees of expectation as you go through to the finished product. But obviously the expectation is to roll, as it usually is to roll downwards to the base manufacturer and say you have to be uncrackable, if you like, in order to be adopted into our system, and then it rolls from there. But we are spending a lot of time looking at the security of our devices.
So you just did a great job of going from your suppliers to your customers, which I think is exactly right? Because you need to be really seamless in your thinking. There's another challenge that I see, and that is we talk about this Internet of Things, the Internet of Tomorrow, and we talk about devices as if they're homogeneous, as if they're all very similar, but in reality they're not. You made the point, the Fitbit versus the GPS in your car, or better yet, some security feature or safety feature in your car. How do you look at those differently? Do you look at them differently, and what are the keys to how Freescale thinks about that?
I think the critical part of this is to look at the end functionality. So if you're designing something which will have a high degree of data privacy requirement, if you like, related to the individual, then you're going to want to have something different versus purely like a heart monitor, or a pedometer, or an inclinometer, potentially, just for monitoring something you might put in a tennis shoe. So part of it's going to relate to where you think that end application is going to be. But you also need to be thinking about, for each of those devices, what's the most stringent use that you could possibly have applied to it. So you're designing and you're thinking about, what do I have to safeguard to at the extreme for this device and work back? Almost like we do in test or in anything else related to product, but it becomes at a software and a design level as opposed to a test or a hardware level.
Cool, thank you. So we talked about this a little bit before. You know, with the trillion sensors on the horizon, the possibility, the potential for all of that, you and your suppliers are having to innovate at levels that are really unusual, almost unheard of. How do you make that work? When you think about the suppliers that are really working for you, what makes them stand apart, and how do those innovations look?
So from a Freescale sensor standpoint, I think we've clearly defined who our partners are, who we see as the companies that are willing to work with us, jointly shared on development thought processes, development costs as we move forward. Freescale as a whole, obviously we have wider contracts with various hardware manufacturers. But if I focus down into sensors, it's picking partners who will stay with you, picking the right subcon that will work with you, and have a degree of flexibility and fungibility around those next generation products, that they're not scared to invest, that they can see that the benefit that's coming to them based on your history and also the demand that you see down the road as well. So it's quite complex. You can't leave a high and dry, if you like, partner. There has to be a degree of faith and trust in anything along those lines. But when you choose a partner, executing, committing with them is going to be important. And vice versa. They have to execute and commit to what they're promising us. And that's really where we're trying to go, is a limited number of partners that we see as going to be the winners, if you like, who have the product, the hardware that we need, who have the ability to be flexible with us, who have the ability to scale with us as we require scaling.
Same lines, you know, there's a risk profile that both you and your partners are accepting. How would you describe that, and how would you describe approaching it from a business perspective?
I think the risk profile is dependent. So it's going to be dependent on whether this is an initial launch of a technology or a specific product in a technology, or if it's a diversified product, or just a me too. Next generation, something that you have some degree of capability or some degree of history in. So I think what you have to look at is to say, how am I defining the risk of an initial technology, for example, and what am I doing as the manufacturer, the designer, if you like, in order to mitigate that risk? And what does that mean for you, Mr. Partner? So how can you help me mitigate the risk, and how can I help you do that? So working with them in early stages in development is critical. Then as you move forward, it's into, well, how do we proliferate? So what's the risk of the proliferation? Have we met the window for the market? So is the demand going to stay there? And if so, what does that really mean? How accurate are you at calling that demand? So those factors all have to play into almost your risk assessment. This is where we are on product A, B, C, D. And you can fairly comfortably do an assessment. It's having the right milestones and checks and balances in place that say, are we meeting this requirement? Has anything changed? Yes, no. If it's changed, what do we do about it? So helping manage the risk as you go through a project or a product with a partner, I think, is critical.
So this one is to help tie to Brandon's conversation later. You talked an awful lot about wafer level chip scale packaging, and it's emerging still. Many of the pieces of equipment are not yet really available. What are the critical pieces of that, and what has to come forward quickly, in your opinion, to really enable success?
From a sensor standpoint, wafer level CSP is in the early part of its development, shall we say. We don't have a lot of opportunity or available systems today that would allow us to quickly move and scale. So we're having to walk forward with what's available today. The expectation is as it becomes more developed and more adopted, that those kind of opportunities and the range of equipment will broaden. So what really needs to happen quickly is the ability, one, to be integrated, and two, from a sensor standpoint, is what can you do if you require some degree of physical stimulus inside that integration, whether it's a pressure test or an accelerometer test or a gyro test or a combination of those at a wafer level. So those will become the critical parts. How can you, if you have to physically stimulate, how would you be able to do that at a wafer level today? And then the next step is obviously to get to the non-physical part of that, electrically replicating that physical behaviour. Those are for me, the two stages that we have to go through.
So you've been at Motorola Freescale for a very long time, and you've seen tremendous transitions and transformations. What are the most interesting ones that you've seen, and what are the ones that you're really looking forward to?
The interesting transitions for me have been how businesses that were once enormous businesses have gone. So it's understanding that this is not a permanence. You can lose business and you can gain business fairly quickly. If you look at the wireless business inside Motorola Freescale, we were supplying Motorola cell phones predominantly. That business is gone. Whereas some other businesses, straight microcontroller businesses, RF power business, have grown dramatically over that time period. So the proliferation of the network has been huge. I joined the RF team back in 1999, was there for 3 years, and that business is much larger today than it was then, through technology development, much more use of plastic thermal packaging, for example. That business has grown, along with the proliferation that we talked about earlier on Internet of Things. So that's been a really incredible change for me, just to see how businesses which were once almost seemed impermeable have gone. Looking forward, I really look forward to how we are able to combine across Freescale our opportunities in the Internet of Tomorrow. As I talked about earlier, we have the microcontroller, we have the networking processor, we have the RF, we have the analog, we have the sensor. We should be able to drive for ourselves a huge future. And so it's making sure we execute to that future, capture the possibilities and opportunities, and execute to that. I think that's really exciting for us. It's a huge new market, huge new world. Internet of Tomorrow is coming, so it's exciting to see us go and bet our future partially on that Internet of Tomorrow and ensure that we execute to win.
So I'll let you decide whether he turns the camera off for this next one, but you're about to become part of a different company. Mm-hmm. How does all of that feel? What do you think is the promise of that for your customers and your suppliers?
Okay, from a personal standpoint, I think it's very exciting. To have the scale of a combined company, which will be a $10 billion company versus a $4 billion company, and to have the liquidity which we will have as that company, drives, I think, a greater opportunity to go execute on our key goals and our key opportunities in the market. So for me personally, I think it's extremely exciting. I think for Freescale, it's also a time to take those opportunities we talked about across our portfolio and add it to what already exists, which is very complementary in nature, to drive forward from there. So I see it as nothing but positive, frankly, as we go forward.
Cool.
Is there anything we didn't cover? No, I think we talked about sensor future, we talked about Freescale future, I think we talked about what's important from a test development standpoint. I think we covered the hot topics. I think we're good.
You're great to interview. Will you do me a favor?
Of course.
I know Greg Lowe from his days at
All right.
TI. Would you tell him I said hello?
Of course.